Uh, okay, so now we're gonna obtain a little bit more information about the directional derivative and the gradient by looking a little bit more closely at the formula. So we've seen that the directional derivative can be written as a dot product, right? So exactly this dot product here, where the directional derivative is the dot product of the gradient with the direction vector. And so going back to way back to the previous discussion about the dot product, we've seen that so section 12.3 so scrolling down, we've seen that the dot product can be related to the angle between the vectors according to this formula here. And so basically applying this formula to this dot product for the directional derivative, you get this expression here where you have the magnitude of the gradient times the magnitude of the unit vector times cosine theta, where theta is the angle between the gradient vector and the direction vector. And then also we've taken the direction vector to be a unit vector, right? So this magnitude is equal to 1, so we get exactly this expression here. And now furthermore, we can see how this expression changes in value as the angle changes, right? So first of all, the cosine function is always between -1 and +1, and in particular, when the angle is equal to 0, we get a cosine of 1, and that's the maximum possible value for this expression. And so we can say that the directional derivative is maximized when the angle is equal to 0, which is the direction where the direction vector is in the same direction as the gradient vector. Similarly, when the angle is pi or 180 degrees, then cosine is -1, and so that's the smallest value that this expression can take. And so smallest meaning most negative, right? So that's the direction where the direction vector is opposite the gradient vector. And finally, if the angle is 90 degrees or pi over 2, then this expression is equal to 0, and the direction vector is perpendicular to the gradient vector. So this is all summarized in this little table here, right? So it says that the maximum rate of change is when this cosine is 1, so that's just this value here, and occurs in the direction of the gradient. The minimum value is when this is negative, right? So when the cosine is -1, and it occurs in the direction opposite of the gradient, and this is equal to 0 when they're perpendicular. Okay, so let's use this information here to look at example 2. So we're asked to find the maximum rate of change for this function at this point, and also to determine the direction that it occurs in, right? So this is exactly the situation labeled 1 here in theorem 6.3, right? So specifically, we want the maximum rate of change, and it occurs in the direction of the gradient. Okay, so and the value is equal to this, right? So basically, we just need to calculate the gradient. So the gradient of f, again, is just the vector with the partial derivatives. So what is the partial derivative with respect to x? So this term gives 2x, and this term doesn't contain any x, so this term goes away. Now the partial with respect to y, this term goes away, and we just get 2y. So this is the gradient, and now we want to calculate the gradient at this point here, right? So this is my point A, B. So the gradient evaluated at the point 1 comma 3. So x is 1, right? So this is 2 times 1, and then y is 3, so this is 2 times 3. So I get the vector 2 comma 6. Okay, so that's the gradient here, and then now I have to calculate the magnitude. So just now the magnitude of this vector, right? So square root of 2 squared plus 6 squared. So what is this? 6 squared is 36. 36 plus 4 is 40. So I have the square root of 40. So this is the maximum rate of change. Okay, and then now what the direction? The direction is the direction of the gradient. But let's write it as a unit vector, right? So so u is going to be the gradient divided by the magnitude of the gradient. So we will calculate the magnitude as the square root of 40, right? So it's just going to be 2 over square root of 40 comma 6 over square root of 40. Okay, so this is going to be my direction. Okay, so that's example 2.